Alright guys, we're going to continue to talk about graphing quadratic equations. Today we're talking about horizontal shift. Okay, so in my class this is objective 3.2b, but regardless we're talking about graphing quadratic equations and shifting them horizontally. So just a quick reminder, a quadratic function is always based off of the graph of f of x, which is what I have here. It's what the table is for, it's what the graph is for. The graph of f of x equals x squared is the most basic quadratic function. It creates a parabola, which is a U-shaped graph. The vertex is always located at the origin, or 0, 0. The x and y intercepts are also located at the origin. Since f of x squared is a positive function, the parabola faces upward, meaning the U-shape faces up. The ends of the graph, or the arrows, help us determine the domain. So if we look at the arrows and we look at the x values are negative infinity and positive infinity. That gives us our domain. The range of the graph of the function can be found by looking at the y values of the vertex and the arrows. So the vertex, I colored in blue, the y value is 0, and at the arrows, both my y values are positive infinity. So in this case, my range goes from 0 to positive infinity, which you can see highlighted in purple and written in blue in the lower right-hand corner of that graph. Range is 0, infinity. The axis of symmetry is the line that splits the graph into two even symmetrical halves, which in this case, I have it dotted in blue on that graph. It's the axis of symmetry is x equals 0, or the y-axis. So this is the most basic function of a graph, and we're talking about shifting this graph up and down, left and right, narrowing it and widening it. Today we're going to talk about how to move the graph left and right. So to move this graph left and right, we're actually going to look at an example below. Moving the graph of f of x squared left and right. So there's two things that could happen. You could have f of x equals x plus h, or f of x equals x minus h. This is how we shift left and right. X plus h shifts the graph to the left. X minus h shifts it to the right. Now, it's kind of backwards from what you would think, and this does trip students up, so you need to remember those 2 points. They're very important. If it's x plus h, we're going to the left. If it's x minus h, we're going to the right. So first of all, we're going to graph this function. We're going to identify the vertex, the x and y intercepts, the domain and range, and the axis of symmetry. So we do have kind of a bit to get done here. So the first thing I want to understand is f of x equals x minus 3 squared. This right here, x minus h, this tells me that it's going to shift to the right. And that means that if my original graph sits on the origin, my new graph, f of x equals x squared minus 3, is going to shift it to the right 1, 2, 3 units. And that's where my new graph should be by the time I'm done with this. So let's go ahead and look at it. So what I want to do is I want to make a table. To make my table, I'm going to choose x values, plug them into my function, and end up with y values. This should give me coordinate points to work with. Your table doesn't have to be pretty, just try and get it on there as best you can. Okay, if you have a ruler, that works. I always choose small values. What I want to try and do is choose a value that will make x minus 3 equals 0, because that's always a nice point to start. To choose a value where x minus 3 equals 0, 3 minus 3 is 0, so my middle number is going to be 3. And then I would pick numbers on either side of that. So going in a negative direction, I would have 2 and 1. Going in a positive direction, I would have 4 and 5. So again, the reason I chose 3 is because when I plug this in, 3 minus 3 is 0, and 0 squared is 0. I want to always have a small number to work with, something easy. So if I do this for the rest of these points, if I plug them in, subtract 3, and square them, I'll end up with the rest of my y values. So I'm just filling this out. Let's get started. So I'm going to plug in 1, 2, 4, and 5. 1 minus 3 is negative 2, squared is positive 4. 2 minus 3 is negative 1, squared is positive 1. 4 minus 3 is 1, squared is positive 1. 5 minus 3 is 2, squared is positive 4. This is going to give me my coordinate points, or my x and y values. And I can easily plot these on my graph. So I am going to bring out a ruler just to make my coordinate plane. Since these are all positive values, I'm just going to shift this y-axis over a little. I don't really need negative x values. I'm going to put a couple in there just to show you, but I don't really need them because all my points have positive values. So this is my x-axis, this is my y-axis. My first point is at 1, 4, so on the x-axis 1, on the y-axis 4. First point. 2, 1, 3, 0, 4, 1, 5, 4. And right there. Okay. So we're going to connect these points with a line and arrows on both ends. From here, I was asked to find the vertex, the x and y intercepts, the domain and range, and the axis of symmetry. Okay, so I'm going to just make a list of things that I need to find. I'm going to put them over here to the side. So I need to find the vertex, the x-intercept, y-intercepts, the domain and range, so D and R, and the axis of symmetry. So let's start with the vertex. Remember, the vertex is where the graph stops going down and starts going up, because we read a graph from the left to the right, meaning I start at the left arrow, work my way along the graph until I'm at the right arrow. So if I'm starting at the left arrow, it's going to go down, 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 down till it hits this point. Then it's going to work itself back up. So the point where I stopped going down is called the vertex. So I know the vertex is right there, and that's at the point 3, 0. So that's going to be my vertex, 3, 0. My x-intercept is where the graph crosses the x-axis, and it crosses the x-axis at one point. I'm just going to try and make that a little smaller. It crosses the x-axis at one point. That point is again here at 3, 0. So this is going to be my x-intercept. Oops. Pardon me. 3, 0. Don't know what I was doing there. My y-intercept, it doesn't really show, based on the graph that I have, what my y-intercept is. I do know that it's where the graph crosses the y-axis, and if you look at that green arrow, it doesn't quite hit the x-axis. What we can do is we can solve for it. I know that my y-intercept means that my x value has to be 0. So I can take my equation, which is y equals x minus 3 squared, and replace x with 0. So y equals 0 minus 3 squared, or y equals negative 3 squared, so y equals 9. This means that my y-intercept is at the point 0, 9, which would probably be around here. Okay, my domain and range. Okay, domain and range. Domain. Domain deals with the x values. Of your arrows. So this left arrow has the coordinate point negative infinity, positive infinity. Because it's going forever to the left, so forever towards negative infinity on the x-axis, and forever up, so towards positive infinity on the y-axis. My right arrow has the coordinate point positive infinity on the x, positive infinity on the y, because the arrow means it's forever stretching to the right and also forever stretching upward. That's why it has that coordinate point. So for our domain, we care about the x values, which is negative infinity, positive infinity. So from the smallest to the largest is how we write that, negative infinity to positive. The range cares about the y values from the vertex to the arrows. So my y value on the vertex is 0, and on the arrows it's infinity. So my range goes from the smallest to the largest, so from 0 to positive infinity. The axis of symmetry is the vertical line that cuts the graph in half, which you don't see on the graph, but you can create by drawing a vertical line cutting this graph in half. And the vertical line is always written as the equation of x equals wherever the x value is on that x-axis. In this case, it is 3. So x equals 3 is our axis of symmetry. Just to give you a hint, the x value in the vertex and the axis of symmetry will always match up. So if in the vertex x was 4, x equals 4 would be your axis of symmetry. In this case, it's 3, so our axis of symmetry is x equals 3. One final hint before I let you guys go is that the domain is always going to be from negative infinity to positive infinity. Always, always, always. Just a hint. But this was moving a graph from left to right, or horizontal shifting of a quadratic function. Have a good day, guys.